Lynn and Diego are discussing two expressions, x squared and 2 to the power of x. Lynn says, I think the two expressions are equivalent. Diego says, I think the two expressions are only equal for some values of x. Do you agree with either of them? Explain or show your reasoning. Okay, so when Diego says for some values of x, and Lynn says equivalent, I think equivalent means it would have to be equal for all values of x. So I'm going to put a little note there, equal for all values of x. Now, I think we have a couple of different ways that we could figure out who we should be agreeing with. One way might be to make a little table and we'll just pick some values of x. So let's say if I pick some values of x, let's say I pick 1, 2, 3, 4, 5, and let's get some big numbers like 10. And let's figure out what our x squared would be and what our 2 to the x would be. So x squared, so 1 squared is 1, 2 squared is 2 times 2, which is 4, 3 squared would be 3 times 3, which is 9, 4 squared would be 4 times 4, which is 16, 5 squared would be 25, and 10 squared would be 100. Okay? Now 2 to the first power would be 2, because that's 2 times itself one time. 2 to the second power, 2 squared would be 4. Oh look, I see a 4 and a 4 there. 2 to the third power would be 2 times 2 times 2, which is 8. 2 to the fourth power, 2 times 2 times 2 times 2 would be 16. And then, oh, look, I see another match right there. 2 to the fifth power, 2 times 2, 2 times 2 plus another 2. That's basically the 16 times another 2. So that's 32. And then, 2 to the 10th power. Good thing we have the calculator over here. Let's do 2 to the 10th power, and we get 1024. Okay, so I definitely don't think it's for all values of x because we only had a couple of matches here. And it looks like it's probably not going to be matching up ever again, really. So we should agree with Diego. I could say, I agree with Diego. And another way that we could verify this is, since we do have the graphing calculator over here, why don't we just graph these? Let's put y equals x squared. And let's also put y equals 2 to the x, 2 to the x. And we'll actually see over here on the graph that it looks like there's an intersection point there at 2, 4, which we saw here. And then there was another intersection point up here at 4, 16. But then we noticed that these graphs, they're not the same. These graphs are not on top of each other. There's definitely some differences in those lines. Especially on the right side, they look a lot closer, but over here on the left side of the graph, these are definitely going in different directions. This one, the green line's going over this way, but the blue line's going back up again.